In the previous class, I have given already the definition of continuity and limit of function of two variable. Now let us solve some of the problems. Now, while solving the problem on limits and continuity, say if you want to find the limit or continuity of the function as xy goes to ab, we have to make an assumption that y is equal to mx plus c. That is a straight line relation between the two variables. And while solving the limit, you have to replace y by mx plus c so that this is a change to function of single variable. But while solving the problems, we discuss only the problem on xy goes to 0, 0, and here you have to take let xy goes to 0, 0 along y is equal to mx. Because when x and y are origin, the value of c becomes 0. Therefore, the relation between x and y changes to y is equal to mx. So therefore, take care of this and you can solve any problem on limit and continuity. Now the first problem. Evaluate limit x comma y tends to 0, 0 of x squared y squared divided by x squared plus y squared. As I told you, here you have to take let xy goes to 0, 0 along y is equal to mxy, because you have to evaluate the limit at the origin. So therefore, make this assumption. Therefore, now limit xy goes to 0, 0 x squared y squared divided by x squared plus y squared is equivalent to limit x goes to 0. Now no need to write limit y goes to 0 here. So what is the change that should be made in the function? That is x squared. Your y is replaced by m squared x squared. Here again, this y is replaced by m squared x squared, and you can evaluate this limit further steps like this. Limit x goes to 0. Here x to the power of 4 cancels and you are left with x squared m squared divided by 1 plus m squared. Now when you substitute the value x is equal to 0 here, this is equal to 0. And we know that it is a problem of function of single variable and 0 is a finite value, hence limit exists. Therefore, we say that limit exists and is equal to 0. Suppose this limit is not finite or it is oscillatory, then we say that limit does not exist. Now let us take the second problem. Evaluate limit x goes to 0, y goes to 0, xy divided by x squared plus y squared. Again, as usual, you have to make the same assumption. Let xy goes to 0, 0 along y is equal to mx. So with this assumption, the problem of limit x goes to 0, y goes to 0, xy x squared plus y squared becomes limit x goes to 0, x, y is replaced by mx, x squared, m squared x squared. Here x squared cancelled and we write limit x goes to 0, m is remaining in the numerator. In the denominator, we are left with 1 plus m squared. Why? Because x squared is cancelled and this value is equal to m plus 1 plus m squared. Why? Because you don't have x value here. So here m is a value, but remember it is depending upon m here. The right hand side depends upon m here. So it is not unique. So therefore, we say that limit does not exist. So as it is not unique, this is not unique. Therefore, we say that limit does not exist. So I think I have given you the two examples. One on the limit exists where limit is equal to 0, and other one where the limit does not exist. Now I think you have followed the method. Let me give you some problems. You try to solve these problems on your own and send the answer to me through WhatsApp. So first problem, homework problem. Evaluate limit x goes to 0, y goes to 0, x square y, x square plus y square. Just I'll give the hint. As usual, you have to replace y by mx, and here also y by mx. What happens here? X is remaining after replacing y by mx. Therefore, when x is 0, the limit is 0 here. Therefore, limit exists and it is equal to 0. Now, second problem, evaluate limit x goes to 0, y goes to 0, x square minus y square divided by x square plus y square. Again, I will give a hint here. You just replace y by mx so that x square minus m square x square, x square plus m square x square. What happens here? X is cancelled in the final state, and we are going to get a value which depends upon m, which is not unique. Hence, limit does not exist. So please try this problem. If you have any difficulty, you can call me and clarify your doubts. Now, let me try to solve some of the problems on continuity. As you know, the function is said to be continuous. A function of two variable is said to be continuous at x is equal to a and y is equal to b if limit x goes to a, y goes to b, f of xy is equal to f of ab. That means the limit of the function is equal to the value of the function. Then we say that the function is continuous. Now let us solve one or two problems on continuity. The problem will be, first problem, let the function f of xy is defined like this. It is xy divided by square root of x square plus y square when xy not equal to 0, 0, 0 when xy is equal to 0, 0. Show that the function f of xy is continuous at the origin or 0, 0. Now, first of all, you have to find the limit of the function as x goes to 0, y goes to 0, and then try to compare this with f of 0, 0. Here, what is the value of the function at 0, 0? It is equal to 0. It is given very clearly in the given function. So therefore, you have to know this because the continuity is depending upon the limit as well as the value of the function. Now, let us try to find limit x goes to 0, y goes to 0, f of xy. See here x tends to 0, y tends to 0. That is, x and y both are tending to 0, but they are not equal to 0. Hence, the function is limit x goes to 0, y goes to 0. The function is xy divided by square root of x square plus y square. Now it's a problem on limit. You know that how to solve it. So you have to take as usual y is equal to xy goes to 0, 0 along y is equal to mx. So using that idea, I can write this as limit x goes to 0. This is x, m into x, because y should be replaced by mx, square root of x square m square plus x square. When you simplify this, it is limit x goes to 0. Here I can take x square outside the square root, becomes x here. One of the x get cancelled. You will get m into x divided by square root of 1 plus m square. Here m and square root of 1 plus m square are definite numbers, and when you substitute x is equal to 0, this becomes 0. Now we know that this is equal to f of 0, 0, because this is already given here. So limit of the function at x is equal to 0, y is equal to 0 is equal to the value of the function. Hence, from the definition of continuity, we say that therefore f of xy is continuous at 0, 0, or you can say that at the origin, because 0, 0 is nothing but the origin. I hope this is very clear. So therefore, first you have to evaluate the limit and try to equate this to value of the function. If they are equal, then we say that the function is continuous at the origin. Now I'll try to solve one more problem. The problem is like this. Let f of xy is equal to x plus y if x not equal to 0, y is not equal to 0, 1 otherwise. See, the problem is asked in a different manner. If you compare this with the first problem, here x not equal to 0, y not equal to 0. But otherwise means this is the case when x is 0, y is 0. Because the negation of x not equal to 0, y not equal to 0 is x is equal to 0, 0. So please try to understand. The question may be asked like this. Actually, what is the meaning of this one? This is value of the function at x is equal to 0, y is equal to 0. Therefore, there is the first point, f of 0, 0 is equal to 1. That is the meaning here. So that you have to verify clearly. Now, as usual, try to find the limit as x goes to 0, y goes to 0, f of xy. It is limit x goes to 0. You make the same assumption that xy goes to 0, 0 along y is equal to mx. That means here we have to write first of all this one, then that assumption x plus mx, and this is limit x goes to 0, x into 1 plus m, and like this. Because x is 0 here, this is equal to 0. But what is the value of the function? So it is not equal to f of 0, which is equal to 1. The value of the function is not equal to the limit of x goes to 0, y goes to 0. Therefore, what you can say here, we say that the function is not continuous at the origin. So you have to check the continuity at the origin here. I think I have not mentioned that one. So the problem is you have to check the continuity at the origin. So therefore we say that here the function is not continuous at the origin. So I will solve some more problems based on continuity and limit. I will send through the notes. I hope you have followed the problems. Thank you.